Welcome, dear dreamers, to Starlit Science Stories, where we embark on gentle, curiosity-fueled voyages through the wonders of science, designed to send you drifting into sleep a little wiser, a little more curious than before. If you're joining us for the first time, a warm hello. If you're a returning voyager, it's a joy to have you back, nestled in your cozy corner of the world. Tonight, we're setting our sights beyond the familiar pull of Earth into the vast, quiet expanse of space, where up and down fade into memory and the ground becomes a distant suggestion. Our journey is not about the roar of rockets or the thrill of exploration, but something softer, deeper, and infinitely more mysterious: gravity. This is the force that pins your feet to the floor, keeps your tea from floating away, and weaves the stars into their cosmic tapestry. It's the silent architect behind galaxies, the gentle nudge that sends your toast tumbling jam side down, and the invisible thread connecting you to the universe itself. Tonight, we'll explore what it feels like to slip free of gravity's embrace, to float in the vacuum of space, and to uncover what this weightless world reveals about the force that shapes our lives. What happens to astronauts when they orbit Earth? How does gravity mold our bodies, our minds, and our understanding of reality? And how did a certain wild-haired physicist named Einstein turn our perception of gravity inside out? We'll wander through these questions in a calm, sleep-friendly way, letting the mysteries of the cosmos lull you into a state of quiet wonder. I must warn you, though, this journey might be dangerously fascinating. If you find yourself lying awake, pondering the curves of space-time or the dance of distant stars, well, that's a fair trade for a sprinkle of cosmic insight. No need to worry. We're here to relax as much as to learn. Before we launch, I have a small favor to ask. If this journey sparks your curiosity or soothes your soul, please consider giving this video a like and subscribing to The Sleepy Scientist. It helps guide more wandering minds to our little corner of the universe. And if you feel like connecting, drop a note in the comments. Where in the world are you watching from, and what time is it right now? I love imagining you all, scattered across the globe, from the misty fjords of Norway to the warm beaches of Bali, from midnight to early morning, curled up with a blanket, a cup of chamomile, or maybe a purring cat, all united by a shared love of soft science and quiet stories. It's a comforting thought, isn't it? Knowing that somewhere, someone else is listening, wondering, and drifting off under the same starry sky. Now, wherever you are, I hope you're settled in. Perhaps you've dimmed the lights, fluffed your pillows, or turned on a star projector, casting tiny constellations across your ceiling. Maybe your dog is snoring softly, or the hum of a distant city filters through your window. Take a deep breath, let your shoulders soften, and allow your mind to wander. We're not in a hurry. We're not chasing answers. We're simply floating, carried by curiosity into the heart of the cosmos. In space, there's no up, no down, just motion, curves, and an endless quiet. Astronauts describe the sensation of microgravity as both liberating and disorienting. A gentle push sends you gliding across a room. A twist lets you spin like a slow-motion acrobat. Your pen drifts past, your water bottle hovers, and for a moment, it feels like gravity has vanished entirely. But here's the secret: it hasn't. Gravity is still there, playing a cosmic sleight of hand. What feels like weightlessness is really a state of perpetual free fall, a perfect balance of motion and force that tricks your senses. Tonight, we'll unravel that trick, drifting from the International Space Station to the minds of Newton and Einstein, from the human body's quiet rebellion against weightlessness to the grand architecture of galaxies. We'll explore black holes, gravitational waves, and even the possibility that gravity itself might be an illusion, a shadow of something deeper. But we'll move slowly, gently, like a leaf on a calm stream. This isn't a race to the stars. It's a soft drift through the invisible web that binds the universe together. So, take a moment to feel the gravity beneath you, the weight of your body against the bed, the gentle pressure of the earth holding you close. It's been with you since your first breath, a constant companion. For the next little while, we'll imagine loosening its grip, floating beyond its reach, and discovering the secrets it's been whispering all along. Because sometimes, the best way to understand something is to step away from it, to see it from a distance, and to let it surprise you. All right, sleepy scientists, let's begin our journey, floating in a vacuum. What space teaches us about gravity? Chapter 1, The Nature of Gravity. What is gravity? It's one of those questions that feels simple until you try to answer it. You might say, it's what makes things fall, and you wouldn't be wrong. But that's like saying sleep is what happens when you close your eyes. True, but it barely scratches the surface. Gravity is the force that keeps your feet on the ground, your book on the table, and the moon tethered to Earth. It's the reason planets orbit stars, stars gather into galaxies, and galaxies weave into the vast cosmic web. Yet, for all its ubiquity, gravity remains one of the universe's great mysteries, a force we feel every moment but struggle to fully understand. Let's start with a story from the 1600s, one that's become almost mythical, Sir Isaac Newton and the falling apple. Historians now believe the apple didn't actually hit Newton's head, but it did spark a revelation. Watching an apple drop in his garden, Newton began to wonder why it fell straight down and not sideways or upward. This led to his groundbreaking insight. Gravity is a universal force, an invisible pull between objects with mass. You, me, the earth, your cat, we all exert a tiny gravitational tug on each other. The earth, with its immense mass, pulls much harder, which is why you stick to its surface rather than drifting off to greet the neighbors. The sun, even more massive, keeps the planets in their elegant orbits, holding the solar system together across 93 million miles of space. Newton's laws of gravity were a triumph. He proposed that the strength of gravity depends on two things: the mass of the objects and the distance between them. More mass means a stronger pull, closer proximity amplifies it. This simple formula explained why apples fall, why the moon circles Earth, and why comets trace their long, looping paths through the heavens. For over 2 centuries, Newton's equations guided astronomers, engineers, and curious minds, predicting everything from planetary orbits to the trajectory of a well-aimed snowball. It was a model of elegance and precision, and it worked beautifully for the world we could see and touch. But then, in 1915, a German physicist with wild hair and a penchant for thought experiments turned everything upside down. Albert Einstein introduced his theory of general relativity, a radical reimagining of gravity that went beyond Newton's force. Einstein proposed that gravity isn't a pull between objects, but a curvature in the fabric of space-time itself. Picture the universe as a vast, stretchy sheet. Place a heavy object, like the sun, on it, and it creates a dip. Roll a marble, like Earth, nearby, and it spirals inward, not because it's being tugged, but because it's following the curves of the sheet. In Einstein's view, planets don't orbit because they're pulled. They move along the straightest possible paths through a universe that's been warped by mass. This idea is both beautiful and mind-bending. Space-time isn't just space. It's a 4-dimensional blend of space and time, woven together into a single continuum. Massive objects bend this continuum, and those bends dictate how things move. Even more astonishingly, gravity affects time itself. In stronger gravitational fields, time flows slower. This isn't science fiction, it's measurable. Clocks on GPS satellites, orbiting where gravity is slightly weaker, tick just a fraction faster than clocks on Earth. Without correcting for this, your phone's navigation would drift wildly off course. Even in your own body, time moves ever so slightly faster for your head than your feet, though the difference is far too tiny to notice. Newton's gravity works for everyday life. Falling apples, orbiting moons, tossing a ball. Einstein's gravity shines in the extremes, near black holes, around massive stars, or in the subtle drift of satellite clocks. Both perspectives reveal gravity's quiet power, its role as the universe's choreographer. It shapes the tides, the seasons, the arc of a shooting star. It's why your body sinks into your mattress, why your breath feels steady, why the world feels solid beneath you. As you lie there, let this idea settle softly. Gravity isn't just a force, it's a connection, a silent partner in every moment of existence. Before we drift further, let's pause to imagine the stars above you, each one held in place by gravity's gentle hand. In the next chapter, we'll leave Earth behind and float into orbit, where gravity plays a stranger game and weightlessness reveals its secrets. Chapter 2. The Illusion of Weightlessness. Imagine you're an astronaut 400 kilometers above Earth, aboard the International Space Station. You push off a wall, and your body glides effortlessly, twisting and spinning in slow motion. A pen floats past your nose. A droplet of water hovers like a tiny planet. It feels like magic, like gravity has vanished entirely. But here's the cosmic twist. It hasn't. Even in orbit, gravity is nearly as strong as on Earth's surface, about 90% of its full strength. The weightlessness you feel isn't the absence of gravity, it's the result of being in constant free fall. Let's break it down in the sleepiest way possible. Picture yourself on a roller coaster, cresting the tallest peak imaginable, one that brushes the edge of space. As the car tips forward, it disconnects and hurtles sideways at 28,000 kilometers per hour. You're falling, but the Earth's curve drops away beneath you at exactly the same rate. You never hit the ground. You just keep falling, looping around the planet in a perfect orbit. That's what astronauts are doing, falling sideways, fast enough to miss the Earth entirely. It's not zero gravity, it's microgravity, the sensation of weightlessness created by this endless descent. To understand this, think of an elevator in free fall, a slightly alarming thought. So let's keep it gentle. If the cables snap, everything inside, your coffee cup, your phone, you, floats for a moment because you're all falling at the same rate. There's no floor pushing back against you, so you feel weightless. The ISS is like that elevator, but instead of a brief plunge, it's a continuous, graceful loop around Earth, completing an orbit every 90 minutes. Astronauts don't hover, they fall endlessly, beautifully. This state of microgravity transforms everything. Simple tasks become cosmic puzzles. Brushing your teeth. The toothpaste could float away, a glistening blob of minty chaos. Eating. Crumbs are a hazard, drifting into vents or your crewmate's face. Your inner ear, which relies on gravity to sense down, throws up its hands, leading to nausea or disorientation in the first days. Even your body rebels. Without gravity's downward pull, fluids like blood and lymph drift upward, puffing your face and slimming your legs, a phenomenon astronauts call space face. Your spine, free from compression, stretches, adding up to 2 inches to your height, though you'll shrink back on Earth. But microgravity takes a toll. Without the constant resistance of gravity, your bones lose density about 1 to 2% per month, like accelerated osteoporosis. Muscles, especially in your legs and back, weaken without the need to push against weight. Your heart, no longer pumping against gravity, gets a little lazy, shrinking slightly. To counter this, astronauts spend 2 hours a day exercising, strapped to treadmills with bungee cords or lifting against vacuum-powered resistance machines. It's not about staying fit for selfies. It's about ensuring they can walk when they return home. Living in microgravity is like stepping into a dream where physics rewrites the rules. You don't walk, you glide. You don't lie down. You float in a tethered sleeping bag, cocooned in silence. Yet gravity is still there, orchestrating your orbit, keeping the ISS tethered to Earth's invisible pull. It's a paradox. You feel weightless, but you're never free of gravity's embrace. In the next chapter, we'll step inside the ISS to see how astronauts live in this floating world, where every detail, from food to toilets, is engineered for a life without down. Chapter 3. A Floating Home, Life on the ISS. The International Space Station is a marvel of human ingenuity, a floating laboratory, observatory, and home orbiting Earth at 400 kilometers high. From the outside, it's a gleaming patchwork of modules and solar panels, like a high-tech kite soaring through space. Inside, it's a humming, blinking maze of cables, screens, and tethered tools, where 6 astronauts live in a world without gravity's familiar pull. Life here is a delicate balance, a choreography of floating bodies and clever engineering, all designed to outwit the absence of down. Let's start with something as simple as eating. On Earth, gravity keeps your soup in the bowl, your sandwich on the plate. In space, everything floats. A loose crumb can clog a vent or jam a switch, so food is carefully engineered. Meals come in sealed pouches. Think rehydrated chicken curry or sticky rice, spooned carefully to avoid escapees. Tortillas are a favorite over bread. They don't crumble, sparing the station's delicate systems. Drinks, no cups are pouring. Liquids are sipped through straws with clamps, lest a stray droplet drifts into someone's eye or a critical circuit. Imagine savoring a pouch of coffee, watching it hover briefly before you catch it. A tiny orb of morning warmth. Sleeping is another adventure. There's no lying down when there's no down. Astronauts zip into sleeping bags, tethered to the walls of small, phone booth-sized cabins. Some strap in near the ceiling, others near a console, wherever feels cozy. Floating in a sleeping bag is like resting in a soft cloud, weightless and free of pressure points. Many astronauts say it's the best sleep they've ever had, though some miss the familiar weight of a blanket. Occasionally, a loose strap leads to a gentle drift, bumping into a wall like a wayward balloon until morning. Hygiene requires creativity. Showers are impossible, water doesn't fall. Instead, astronauts use damp wipes and no-rinse shampoo, catching floating water blobs like tiny jellyfish. Brushing your teeth means swallowing the paste or spitting into a towel. Spit doesn't fall neatly into a sink. Toilets are the unsung heroes of space life. Without gravity, waste doesn't behave politely. Space toilets use vacuum suction with foot straps and thigh harnesses for precise alignment. Yes, there's a manual. Yes, astronauts practice on Earth. Urine is filtered and recycled into drinking water. NASA's unofficial motto is, "Yesterday's coffee is tomorrow's hydration." It's not as gross as it sounds. The water is purer than most tap water. Solid waste is sealed in bags, stored, and later incinerated during re-entry, a fiery farewell to the less glamorous side of space. Moving around is its own art form. Astronauts don't walk, they glide, pushing off walls and grabbing handrails. Foot loops and Velcro keep them anchored. Everything else, pens, laptops, clipboards, is tethered or stuck down. A loose item becomes a floating hazard, drifting like a mischievous sprite. Daily life is tightly scheduled. 12-hour workdays filled with science experiments, maintenance, and communication with ground control. Exercise is non-negotiable. 2 hours of running, cycling, or resistance training to combat bone and muscle loss. The space gym looks like a mix of medieval contraptions and sci-fi gadgets, with bungees simulating body weight and vacuums mimicking gravity's pull. For relaxation, astronauts turn to the cupola, a 7-window dome offering breathtaking views of Earth. Picture it: sunrises and sunsets every 45 minutes, cities glowing like fireflies, storms swirling below, the atmosphere a fragile blue ribbon. It's a sacred space, a reminder of home's beauty and fragility. Astronauts video call family, watch movies, no popcorn, crumbs, or read, floating with a book tethered to their wrist. Life on the ISS is cramped, noisy with fans and pumps, and lacking privacy, but it's transformative. It teaches you to cherish water, air, and space, things gravity gifts us on Earth. Gravity's absence shapes every detail, yet its presence keeps the station in orbit, a silent guide. In the next chapter, we'll dive into what microgravity does to the human body over time, revealing how deeply gravity has shaped us. Chapter 4: Gravity's Mark on Our Bodies. Floating in space sounds blissful. No weight, no rush, just drifting like a feather in a breeze. But your body, sculpted by gravity over millions of years, isn't quite sure what to make of it. On Earth, gravity is your constant partner. It tells your muscles to push, your bones to strengthen, your blood to pool downward. In microgravity, those cues vanish, and your body begins a quiet rebellion, revealing just how deeply gravity has shaped you. One of the first changes is fluid shift. On Earth, gravity pulls blood and lymph toward your feet, which is why they swell after a long day standing. In space, with no down, fluids drift upward, puffing your face and slimming your legs. Astronauts call it space face, a puffy, moon-like look that can make you feel like you have a permanent cold. Your sinuses clog, your voice might nasalize, and the extra pressure behind your eyes can cause a condition called spaceflight-associated neuroocular syndrome, SANS. This can flatten the eyeball slightly, blurring vision, sometimes permanently. It's a reminder that even your eyes rely on gravity's gentle nudge. Your bones and muscles suffer, too. On Earth, standing or walking is a workout. Gravity's resistance keeps your skeleton strong and your muscles toned. In orbit, that resistance disappears. Bones lose density at 1 to 2% per month, especially in the hips and spine, mimicking rapid osteoporosis. Muscles, particularly in your legs and back, shrink without the need to bear weight. Your heart, no longer pumping against gravity, works less, shrinking slightly, and leaving you dizzy when you return to Earth. To combat this, astronauts exercise rigorously, 2 hours daily on treadmills with bungee harnesses, cycling machines, or resistance devices that mimic gravity's pull. It's grueling but essential. Without it, returning to Earth would feel like running a marathon after months in bed. Your vestibular system, the inner ear's balance center, is thrown into chaos. It uses gravity to sense up, so in microgravity, it flounders, causing space motion sickness, nausea, dizziness, and headaches. Most astronauts adapt within days, but returning to Earth brings re-entry sickness as they forget to account for gravity. Pens drop, steps wobble, and some try to float out of bed, expecting it to work. Your spine, free from gravity's compression, stretches delightfully, adding up to 2 inches to your height. It's a temporary perk until you realize the spacecraft was designed for shorter people. Back on Earth, gravity recompresses you, sometimes painfully. Even your cells behave differently. Gene expression shifts, immune responses weaken, and wounds heal oddly, offering clues for Earth-based medicine. Space research has advanced treatments for osteoporosis, muscle atrophy, and fluid disorders, turning astronauts into floating guinea pigs for science. The psychological toll is subtler but real. Living in a cramped, noisy station, far from family, with Earth a distant jewel, stirs deep emotions. Astronauts cope with strict routines, calls home, and the cupola's views, but isolation and disrupted circadian rhythms, those rapid sunrises, can weigh heavy. Yet, space transforms perspective. Water becomes precious, air a marvel, gravity a gift. Floating teaches us how tethered we are to Earth's pull. In the next chapter, we'll explore the engineering that makes this possible, where gravity's absence shapes every design. Chapter 5, Engineering Against the Void. Space is a harsh place. No air, no ground, no gravity to keep things tidy. Yet, humans live there, thanks to engineering that wrestles with gravity's absence while respecting its ever-present pull. From rockets to space toilets, every design is a conversation with gravity, a testament to human ingenuity in a world where down is just a memory. It starts with the launch. Escaping Earth's gravity requires immense energy. Rockets must reach 11.2 kilometers per second, or 33 times the speed of sound. Most of a rocket's bulk is fuel, burning in a controlled explosion to hurl a small payload into orbit. The Saturn V, which carried Apollo astronauts to the moon, stood 363 feet tall, yet only a tiny capsule reached space. Gravity is a relentless gatekeeper, demanding vast resources to break free. In orbit, gravity shifts roles. The ISS stays aloft by balancing speed and altitude, falling just fast enough to miss Earth's curve. Spacecraft shapes, like SpaceX's Blunt Dragon capsule, are designed for re-entry, using gravity and atmospheric drag to slow down and dissipate heat. Inside, every detail counters microgravity's chaos. Tools are tethered, panels velcroed, and drinks sealed in pouches with clamp straws. A spilled droplet or stray bolt could wreak havoc, so everything is secured. Air doesn't circulate naturally without gravity's convection, so fans and ducts keep oxygen flowing, filtering CO2 and odors. Yes, space can smell. Think burnt metal and sweaty socks. Life support systems maintain pressure, temperature, and humidity like a high-tech terrarium. Exercise equipment is gravity's stand-in. Treadmills use bungees to simulate body weight, and resistance machines use vacuum cylinders to mimic lifting. Without these, astronauts' bones and muscles would waste away. Toilets are a masterpiece. Gravity-free plumbing relies on vacuum suction, with precise alignment via straps and training. Urine is recycled into drinking water, cleaner than most Earth water, but still a mental hurdle. Solid waste is sealed and later burned up in re-entry. Space suits, weighing 300 pounds on Earth, are weightless in orbit but bulky with mass. They provide oxygen, pressure, and mobility with a safer jetpack for emergency drifts. Every button, handrail, and label is designed for a world where nothing stays put. Gravity's memory lingers in every choice. Launching fights it, orbiting harnesses it, returning battles it again. Astronauts feel its return acutely, collapsing under their own weight or dropping objects they expect to float. Engineering makes space livable, but gravity remains the silent architect. Next, we'll zoom out to see gravity's cosmic artistry, shaping stars and galaxies. Chapter 6, Gravity's Cosmic Symphony. Gravity's influence stretches far beyond Earth, sculpting the universe itself. In the vastness of space, it's not just a force, it's a creator, a weaver of stars, galaxies, and the cosmic web that spans billions of light years. Start with a nebula, a diffuse cloud of gas and dust. Gravity nudges particles together, slowly at first, then faster as mass accumulates. The growing clump's pull strengthens, compressing hydrogen until it ignites in nuclear fusion. A star is born. Our sun formed this way 4.6 billion years ago, a spark kindled by gravity's patient hand. Stars don't form alone. They cluster, drawn by mutual gravity into groups that swirl together, eventually joining galaxies. Galaxies are gravity's masterpieces. The Milky Way, our home, hosts 100 to 400 billion stars, its spiral arms glowing with stellar nurseries and cosmic dust. At its heart lies a supermassive black hole, millions of times the sun's mass, anchoring the galaxy's dance. But visible matter isn't enough. Galaxies spin too fast to hold together without extra gravity. This is dark matter, invisible yet exerting pull, keeping stars from flying apart. We can't see it, but its gravitational fingerprints are everywhere. Galaxies cluster into groups, then superclusters, forming the cosmic web. Filaments of light stretching across voids, like threads in a glowing tapestry. Gravity shapes this structure over billions of years, pulling mass into patterns that define the universe's architecture. It also bends light. Gravitational lensing, predicted by Einstein, warps light from distant galaxies as it passes massive objects, creating arcs or multiple images. This lets us map dark matter and spot faint galaxies, turning gravity into a cosmic telescope. Black holes are gravity's extremes, where massive stars collapse into points so dense that light can't escape. They don't suck everything in, but their pull warps space-time, slowing time and shredding nearby stars. Supermassive black holes, like the one in our galaxy, anchor entire systems, their gravity shaping orbits across light years. Gravity's work is slow, deliberate, crafting beauty over eons. In the next chapter, we'll explore Einstein's revolutionary view, where gravity becomes geometry. Chapter 7, Einstein's Space-Time Revolution. In 1915, Albert Einstein reshaped our understanding of gravity with general relativity, a theory as elegant as it is strange. Forget Newton's invisible force. Einstein saw gravity as the curvature of space-time, the four-dimensional fabric of reality. Imagine a trampoline, place a bowling ball, the sun, in the center, and it creates a dip. Roll a marble earth nearby, and it spirals along the curve, not pulled but guided by the shape. Planets orbit because space-time is bent, and they follow its contours. This curvature affects time, too. Stronger gravity slows time. A clock near a black hole ticks slower than one on Earth. GPS satellites, in weaker gravity, run slightly faster, requiring corrections to keep your navigation accurate. This time dilation is real, measurable, and mind-boggling. Near a black hole, minutes for you could be years for someone far away, as depicted in Interstellar, a dramatic but mathematically sound scenario. Einstein's predictions have been tested rigorously. Light bends around stars, as seen during a 1919 solar eclipse. Gravitational waves, ripples in space-time from colliding black holes, were detected in 2015, a century after Einstein foresaw them. Spacecraft like Gravity Probe confirmed space-time's warping. Yet, general relativity falters at quantum scales, where it clashes with quantum mechanics. Theories like string theory or loop quantum gravity aim to bridge this gap, but gravity remains elusive. It's not just a force or curve, it's a mystery we're still unraveling. Next, we'll ask if gravity is even real. Chapter 8, Gravity is Illusion. What if gravity isn't a fundamental force? In 2010, physicist Eric Volland proposed entropic gravity, suggesting gravity emerges from entropy, the universe's tendency toward disorder. Like heat arising from molecular chaos, gravity might be space-time's statistical push toward equilibrium, not a force or curvature. This could explain dark matter's effects without needing invisible particles, reframing galactic rotation as a quirk of entropic rules. The holographic principle takes it further. Our 3D universe might be a projection from a 2D surface, like a cosmic hologram. Black hole studies suggest information is stored on their event horizons, not inside, hinting that gravity could be a side effect of deeper informational laws. These ideas are speculative, backed by math but not yet proven. They challenge reality itself, suggesting gravity is an emergent effect, like waves on a pond. Yet gravity works. Apples fall, planets orbit, light bends. Whether force, curve, or illusion, it shapes our world. These theories remind us that science is a journey, each answer opening new questions. In the next chapter, we'll explore gravity's role in the universe's story. Chapter 9, Gravity's Cosmic Narrative. Gravity is more than physics. It's the universe's storyteller. From a nebula's first spark to the cosmic web's vast threads, gravity weaves the narrative of creation. It gathers dust into stars, stars into galaxies, galaxies into clusters. It bends light, slows time, and anchors black holes that hold entire systems together. Without gravity, the universe would be a formless haze, particles adrift in eternal solitude. On Earth, gravity is personal. It's the weight of your hand on a book, the pull of a wave against the shore. In space, it's cosmic, shaping the arcs of comets and the spirals of galaxies. Yet, mysteries remain. Is gravity a force, a curve, or an emergent shadow? Theories like entropic gravity and the holographic principle hint at deeper truths, but we're still explorers in a vast unknown. Gravity teaches us connection. It binds us to Earth, to each other, to the stars. Like curiosity, it pulls us closer, urging us to ask, to learn, to wonder. In our final chapter, we'll return to Earth, reflecting on what gravity means for our place in the cosmos. Chapter 10, Held by Gravity. We're back home, grounded, held by gravity's gentle embrace. You're in your bed, your chair, your quiet corner, feeling the soft weight of the world. Our journey, from orbiting astronauts to spiraling galaxies, shows gravity as more than a force. It's a connection, tying you to the Earth, the Moon, the stars. In space, we learned it never vanishes. It hides in orbits, guiding every motion. On Earth, it's the comfort of weight, the rhythm of tides, the pull of home. Space teaches us resilience. Astronauts adapt to weightlessness, their bodies and minds reshaping for a gravity-free world. Engineers build against its absence, crafting suits, toilets, and stations that defy chaos. Einstein showed us gravity as space-time's dance. New theories suggest it's deeper still, a shadow of cosmic rules we're only beginning to grasp. Wherever you are, Sydney at midnight, Seattle at dawn, share in the comments. Where are you and what time is it? We're bound by gravity and curiosity, a global community of dreamers. If this journey soothed or sparked you, like and subscribe for more. Thank you for floating with me. Good night, and may gravity hold you close.